Okay, so like I was just saying, just to show one more time, you just want to use simple things in life to show us what we can do with physics, just to see different things. And we're not always going to have really high pieces of equipment like time gates to see time between point A and B, or have really specific like measurements for distance, but we do want to see how the angle does influence the incline. So all you're going to do is take a notebook, and you're going to take off the front flap, and all you're going to do is make sure it's level on the table, so it will just glide off, and it won't be perfect, but we'll talk about that after. And then after you let the pencil glide off, just record the distance that it takes. That makes sense? Try to make it all the way to this edge right here so it doesn't hit the crack of the next table, because that will actually mess up your results a little bit. Okay? And last thing is just try and measure it with this ruler. It's in inches, which is fine. If we need to convert it to meters later, we will do that. Okay? Go for it. Why doesn't someone also record the results on their phone? Okay, so Pat, hold that still. Let Joe measure. Okay, so is this going to be the higher angle, or is this going to be the lower angle?
Lower angle.
Okay, what's this one?
High.
Okay, so now replicate this on the floor.
Start a low angle.
Awesome. All right, so you guys can have a seat one more time. All right, Brandon, so keep those on your phone for a second, and go ahead and tell me what the results on the table were, according to angle.
All right. The low angle traveled 34.2 inches. Regular angle was 40.1 inches, and the high angle was 45.
So, like you just said, the low angle had the lowest distance, the highest angle had the highest distance. That all made sense, and we were able to tell that angle, if you increase, then the velocity didn't increase. However, we weren't really able to see with what we have up here if mass made a difference, because we didn't really do anything different with the mass, right? So, in the future, if we were to do this again, could we do to add on to that mass of the pencil? What could we do? Or subtract from the mass as well? We could break the pencil, or we could sharpen it as well, right? And so making it smaller in mass, we can show you differences with this as well. So it's just ways of observing this with less utilities and less tools to your side, right? Right, Joe? Yeah. Okay, so what are some factors that could have influenced error within this?
These calculations.
So you're not always going to have perfect calculations on a ruler, and even though it would probably help to have a calculator to your side to help you add up everything, it's also sometimes hard. Can I borrow the ruler for a second? So if we're going ahead and using this ruler and saying, all right, I'm going to measure this by having this at my base and going ahead and using my finger as the point so I know where to relocate the ruler and add on. Am I always using that same point on my finger? Might not be exactly right. And am I using that at the right angle for this ruler? Might not be right. Also, we saw another thing. This pencil, what did it do when it rolled off the ramp? It curved. So Joey, even though he did a good job measuring it, he didn't know where exactly to measure from. We wanted it to do something that was probably consistent with everything. Maybe we should have said the tip, as in this tip right here with the eraser, or the other tip, or maybe the middle of the pencil to make it consistent, right? We didn't do that, so that's another form of error that we had. On the pencil itself, what's an error that could have happened?
Friction on the pencil.
There's friction on the pencil, right. So right here on the green tip, that's a form of friction compared to everything else, right, because it's more rigid. And also, the eraser at the end, if you're dragging an eraser against the table, it's going to like drag, right? But if you're dragging wood against the table, smooth, very easy. So what about off the table? Or actually, let's go back to the incline for 1 second before we move off to the table. So what's one error that could have happened from when Pat was dropping the pencil off of here?
It may not be released at the same velocity each time.
Not the same velocity. What am I looking for?
Same angle.
Same angle, right? So same angle between this and the floor, because we're comparing high, middle, and low, but those aren't going to be the same. But what I'm looking for here is you might not be releasing it from the same point. So you could have been releasing it from right here. Could have been tilted a little bit, and that made the trajectory go a little bit different. So not sure. Also, you didn't always have it right here at the edge of the table. It could have been a little bit further down. It could have been right on the edge. You know what I mean?
Yeah.
So there's always little different factors. And these little different factors, even though it's being nitpicky right now, it shows how specific physics can be with these little experiments. And you never think of it at first, right? When this pencil hit the end of the ramp, what did you hear? You heard a clink. That sound actually causes a change in energy because sound creates a loss of energy. And so loss of energy means you have less kinetic energy. Kinetic energy is 1/2 mv squared. Well, you'll learn more about that in the future because that's more advanced with forces. But the v in that equation is the important thing. That's velocity. If the kinetic energy is decreasing, so is velocity. So the speed decreases as well because of sound. Maybe if we got something that would be quieter, maybe less loss of energy, right? So the last thing, with this ground here, did you always use the same ground, as in the same terrain, or did you move around the folder a little bit? You moved it around a little bit. There's no telling exactly how much different the floor is with this coefficient of friction because we can't see unless we analyze it specifically. But the coefficient of friction on specific parts of the floor could be different. You can't see all those little ridges. It's almost impossible unless you have a really good microscope. So that's how this comes into play. So you see how all those little errors affects how this angle or how this pencil is going to move, especially at the end of the ramp. So we saw the basic thing. Angle does affect it, but all those little things in between, now you can think of that when you're dropping something off a ramp or when you're going to bowl or stuff like that. You know what I mean?
Yeah.
You guys have any questions? Awesome. Uh-oh.